Hello and welcome. In this video, we're going to take another look at our Introduction to Web Development series. In particular, we're going to focus on the history of the World Wide Web, or web for short. To begin with, I want to mention that we are going to be looking at web and web development as opposed to the greater internet, but you have to appreciate a little bit about the greater internet to understand where web development plays its role. And once again, to emphasize, the web and web development is just one part of the internet in general. There are other services that run on the internet, the most common of which are going to be things like file services and our email. So to begin with, what we want to do is we want to take a look at networking and just some basics behind networking. Now, this video is not going to be a comprehensive, in-depth look at networking, but rather it's supposed to give you an overview and a little bit of a history and some of the background and terminology that will help you get a little more familiar than with networking as it relates to web development. And so fundamentally, there are two types of networks. One is going to be a circuit switching style network. And the best example of that I can give you is if you've ever watched an old movie and look, for instance, or watch someone using an old switchboard for telephones where the operator would literally disconnect and reconnect a wire between two jacks. And that would then allow for two different people to be able to talk to each other. And so for that example is a circuit switching network. And in this example here, effectively what we are emphasizing is that if A wants to talk to C, then it has unique path. In other words, there's no other traffic on that path. But the downside, of course, then to this physical connection is that if B wants to talk to C, then the connection from A has to be physically removed and then connected to B. Once again, you'll see that a telephone network is a good example of the circuit switching networks. Now, the one thing that you want to point out with respect to circuit switching networks is there has to be some sort of time delay between switching from A to B. And so that's one of the significant disadvantages of a circuit switching network. The second type, more modern one, and the one that's used pretty much universally at this point, is going to be packet switching. Packet switching essentially allows for A and B to be simultaneously connected, and for that matter, nearly simultaneously communicate with C, depending on the style of network that you have. But the key thing is that the message that is being communicated from A to C, or from B to C, or for that matter, from A to B, has to include some additional information in it. And we'll take a better look at this later, but for right now, just recognize that it's going to have some sort of address associated with it. In other words, it'll tell the switch that the message wants to go from A to C, and there may be multiple switches along the way then that will help route that traffic then from A to C. And likewise, then that first switch would also need to know whether or not it even needs to go further than itself if it was routing traffic from A to B. So continuing this, what are some of the advantages and disadvantages? Well, one way to look at this is the bandwidth of the different types of networks. And so for purposes of our discussion, we're going to define bandwidth as the maximum rate of data transfer across a given path. Now, remember I said with the switching networks that you actually had to have some sort of, or rather the circuit switching networks, you had to have some delay associated with the physical disconnect and reconnect of the wire. And so as a result, that is ultimately going to reduce the overall bandwidth of your system. Now, the big advantage, however, though, with a circuit switching network is because that path is unique, there's no real way for there to have any collisions between different clients. So for instance, if you were communicating between A and C and B was effectively not connected, then there's no way for B to cause a collision in the traffic. Now, From the packet switching network perspective, the advantage, of course, is that you can have all of your clients simultaneously connected, but then you have to have some sort of protocol or some sort of procedure in place that then will determine who can talk, because otherwise you will have a problem with collisions. In other words, A and B can't both simultaneously talk to C without some sort of process or protocol involved in determining what gets sent. Otherwise, you'll have collisions. So that's about as far as we need to know to help understand what we're doing with respect to web development. And the other piece of this, of course, is that remember that virtually all the networks currently in place use packet switching. As I said earlier, a good example of the older networks or the circuit switch networks would be the telephone networks. One of the first examples of our packet switch networks is going to be the ARPANET. The ARPANET, which was designed and built in the late 60s, stands for the Advanced Research Projects Agency Network. It was one of the first widely used packet switched computer networks. And as you can see, it stuck around for quite a while. And as I mentioned earlier, then the idea of packets or smaller chunks of the message then that can be routed by some sort of address. Now we'll take a look at the addresses later, but for right now, once again, we just want to focus on sort of the history and how this evolved, starting with ARPANET in 1969. Another example of an early network is the X25 network. The X25 network referring to both a protocol and the network was established in 1974. And then Usenet, which was another early network that was a distributed system. The idea was it was essentially an alternate to ARPANET. As a matter of fact, it was oftentimes referred to as the poor man's ARPANET. But the idea is that it was sort of built on the legacy then of these earlier networks. The big problem with these earlier networks, and these were not the only three, was that there was limited growth. Why was there limited growth? Well, because each one of these networks typically used their own protocols. In other words, it was hard to get one of these smaller networks to talk to another network because they couldn't agree on their communication mechanism. And so as a result, there was not really this network of networks, but rather individual networks that, if you were lucky, were able to communicate with each other. And so you can sort of think of this as now in today's terms of a bunch of disparate home intranets that couldn't communicate with each other. So obviously this led to a need for standards and for protocols, a formal set of publicly available rules, and the first example, or the best example of this that's relevant to us, is going to be the TCP/IP protocol. We'll take a look at this later on, particularly the IP part, and the addressing associated with it. But the idea is that we would have this transmission control protocol and internet protocol that would sort of help at both the hardware layer, ultimately the MAC address layer, and then into the, we'll see it rather at the application layer, in that this would allow then these earlier networks to communicate and ultimately cause significant growth in the internet. Now, we're not yet here to the World Wide Web yet. And so we want to remember that the World Wide Web is just a subset or a component of the internet and the services associated with the internet. And so now we want to think in terms of the World Wide Web. What did it look like in the early 80s, in the early 90s? Well, much different than it did today. It wasn't just a situation where you could go to a web page, click on a link, perhaps see some pictures, a video, or hear some audio. But once again, there were no standards. And so you can think of this now as that we had these computers, or they had these networks that could now communicate with each other, but they essentially weren't speaking the same language. And the best example I could give you this is, imagine, if you would, for just a second, that you were in a room full of people that all spoke different languages. And for that matter, they may not even be all from planet Earth, for instance. And the idea is that you have to come up with a way first to agree to start and stop communication. And so that might be done maybe with hand gestures, maybe facial expressions, things along those lines. But there would have to be some sort of protocol associated with the communication before you could even start understanding what language they're speaking in, or for instance, what they're even talking about. And so keep those two separate, and you'll understand now that we have not yet gotten to the point of the World Wide Web, or the ability to have web-based communication or web development. And so here comes now the invention of the World Wide Web in 1989. It was actually part of the CERN, or the European Organization for Nuclear Research. It's part of their development. Two key players in this that you see here, Robert, apologize, I'm not going to be able to pronounce his name, proposed the first hypertext system. Now we're talking about the language, if you would, that would then allow for two people to communicate, or in this case, a client and a server. And then Sir Timothy Johns Berners-Lee proposed and implemented then the first communication between a hypertext transfer protocol, or HTTP, client and server. Now, remember that all of this sits on top of what we saw earlier with the TCP/IP protocol. And so effectively, the TCP/IP protocol then allowed for you to handle the start and stop of the communication. In other words, handled it at a lower level. And the HTTP protocol between the client and server then allowed for the conveyance of information from the client to the server. So what are the key components of the World Wide Web, and essentially the key components of this communication? Well, the first is going to be the idea of a uniform resource locator. And once again, to keep this grounded so we can sort of appreciate what this is, there's multiple parts that we'll take a look at. But what you can think of this as a unique address to every, for instance, server on the internet, or every resource then on the internet. And so it's comprised of multiple parts. It tells you the type of service, the physical location, or essentially the address of that service or server. And then the last part of it then might be a specific resource that might be located on that physical server. Now, I'm going to put a little virtual asterisk, if you would, by the word physical server, because that's changed significantly. We'll take a look at the possibility of having virtual servers as well. But for right now, you want to think of this in terms of a physical server that might be sitting on the other side of the country or on the other side of the world. And so there's really three parts then to this uniform resource locator: the protocol associated, or the type of service that you might be trying to connect to, the location of that service, and then the specific resource. Now, these URLs, by the way, work for other services. We are going to focus mainly on web and web development. And as such, then what we want to do is we want to look at the pieces, the critical pieces of the web communication. And that is going to be this HTTP, or hypertext transfer protocol. This is going to be then the rules that will allow for communication between a web client and a web server, or if you want to think of the other way around, the web server responding then to a web client's request. The idea is that all of this, once again, sits on top of anything that's network related. And so technically speaking, you could implement the hypertext transfer protocol on top of even a switched network, a circuit switch network, if you wanted to. So whether it's even a circuit switch network or a packet switch network really technically does not matter. And so from there, then the next concept is going to be the idea of the HTTP web server, which is the component of it that responds to a request from a web client. Now we're going to think of these web clients initially as web browsers. That is not necessarily the case. As a matter of fact, it does not have to be a classic web browser. The web client itself, you can see, can be any number of agents, including something that you can actually write yourself. But effectively, then it has to behave a certain way to be able to both respond to the message that's sent from the server, as well as sending requests to the server. So there's going to be basically some rules that it has to follow. And then the last component of this then is HTML, or the markup language associated with primarily web development. It's not exclusively with web development. However, though, the main use for HTML is going to be in web development. And we'll take a look in depth at the hypertext markup language, or HTML. But effectively, in any of the markup languages, what you have is you have this metadata that's included in with the data that you are ultimately transferring from the server back to the client, and that metadata then provides some sort of structure, if you would, for the data. And so that's pretty much universal in all of the markup style languages. Now, a quick overview of the history of some of the web servers. The CERN, as I mentioned, was the one that where the initiative for the World Wide Web started. The CERN HTTPD is pretty much regarded as the first viable web server. The D on the end, generally speaking, refers to a daemon or a server or service, typically, that in this case, it would be used to respond to requests from a client. This was also written by Tim Berners-Lee, as well as others from CERN. It was implemented in C, and it's generally considered the first web server software. One that came shortly after that was then the NCSA, once again, HTTPD. The idea is then it was from the University of Illinois at Urbana-Champaign, and it was among one of the earliest web servers developed, once again, following the protocols for HTTP. So the idea is that we now got TCP/IP, which will dictate then the networking layer. The HTTP will dictate then the communication between the web server and the web client. And the idea is that each one of these servers then must adhere to the protocols for HTTP. In all of these cases where I provided you both with the date of the first release, but also the date of either the final release rather, or its deprecation. And so in some cases, you can actually still get this code, get an opportunity to play around with it. In the case of some of the earlier web servers, they've been rolled into libraries that you can then use in other software. Probably the earliest, most commonly used web server that's still available is going to be the Apache web server. It's going to be one of the ones that we're going to investigate further, as well as Microsoft's Internet Information Services. Apache in general is considered to be running on Unix or Linux, although it can definitely run on Windows machines. And then Microsoft pretty much limited to the Windows Server or Windows Desktop series. One of the replacements for the earlier CERN HTTPD was actually the Jigsaw web server. It was a Java implementation of the HTTP services, and it was ultimately what deprecated the original CERN HTTPD. And we'll take a little look at the governing bodies with respect to this later. Now, a little later then, we want to take a look timeline-wise at tools like WebBrick. WebBrick represents an interesting change, if you would, in philosophy for web servers. And the idea is that it is actually part of, in this case, the Ruby library that can be used then to create a web server much more dynamically. In other words, you can write code then that would simply run on a server that would generate a web server. And once again, this can be used as a regular web server. It was part of the Ruby and the Ruby on Rails experience, and it was much much earlier than some of its contemporaries now that you're more familiar with, and that is going to be Python and then Node.js. In all of these cases, I've actually provided you with some links to the documentation about how you would go ahead about writing your own HTTP server. And so the idea is, particularly with the Ruby implementation, Python and Node.js, that you can actually in code, for instance, write JavaScript code that would start up an instance of a web server. This has tremendous advantages to the more classical approach, in that you can just spin up a web server for testing purposes, have potentially much smaller footprint, etc. But in all of these examples, they must adhere to the HTTP protocol. Lastly, I want to take a look at Glassfish. And the reason I wanted to point out Glassfish was because it is an example of not only something that can be used as a web server, it also can be written in code or use libraries to be able to launch it. However, the big difference with Glassfish is it can also be used to set up additional services. In other words, not just simply classical web services or setting up a classical web server, but the idea is then you can actually build out endpoints that may respond to different types of traffic. You can do the same thing with Python and Node.js as well, but Glassfish was one of the earlier ones that allowed for you to do that. Now, with respect to the web browsers, this one's a little bit clearer. Line Mode browser, which is an example of an early browser, you could argue was either the first or the second. It's the second one in line after the CERN web client or web browser that was once again developed by Tim Berners-Lee. But the big difference with the Line Mode browser is that it was multi-platform. And to this day, it's actually still supported. The original Line Mode browser, the last release was in 2006, but it's also been rolled into a library. I would like for you to take a few seconds to investigate the Line Mode browser because it's rather interesting and it gives you some perspective on what the web looked like in its earlier days, and that it is going to be a textual representation of the web. And later on came tools like Mosaic. Mosaic was another web browser. Once again, it was widely available, or one of the first that was widely available. It did things like integrating early multimedia such as text and graphics. Once again, things that we take for granted at this point. And then another one was Netscape Navigator. Netscape Navigator has sort of went by the wayside at this point, particularly because in the early 2000s, there was not a lot of development in web browsers. It had sort of stagnated. And what you saw was that some of the companies actually got a little bit complacent. And this is around the time where Microsoft had Internet Explorer, Mozilla came out with Firefox, Apple had Safari, and then Google Chrome came onto the landscape a little bit later. But these companies pushed innovation. And a simple example of this was the idea of having multiple tabs in a browser. That's something that we take completely for granted at this point. But when you take a look at Netscape Navigator and then earlier versions of Microsoft Internet Explorer, they did not even have that feature. And so it was a single instance of the application would be running, not multiple tabs. And so Mozilla Firefox, Apple Safari, Google Chrome, and then much, much later on, then the addition of Microsoft Edge then has really spurred some of the web development on the client side of the web browsers. Now, you also want to take a look at some of these browsers and take a look at the engines behind them, and you'll see that some of them, in some cases, share the same engine. Also, I provided you with some additional links, in this case, a list of web browsers. I would encourage you to take a look at this because this is just a sampling of some of the most common web browsers. Now, moving back to the protocols and the standards, who actually keeps these? Well, the World Wide Web Consortium, or the W3 School, which Tim Berners-Lee helped found in 1994, was responsible then for the organizations for the World Wide Web. And so the standards organization, rather, for the World Wide Web. Keep in mind, once again, the World Wide Web is a subset of the internet. And so as such, then those standards are going to be handled by the Internet Engineering Task Force, or IETF. And the best example of their involvement is going to be with the TCP/IP protocol suite. And so those are going to be the two agencies that are going to be the most relevant to us. And then the last thing I want you to take a look at is this concept of the request for comments. It's a public publication that archives a list of all of the internet and WWW protocols, concepts, and standards. I've actually given you a couple of links to those so that you can actually take a look at some of the protocols, or excuse me, some of the documents associated with the protocols for the TCP/IP standard and other communications. Now, we all know that the web is growing, but at what rate? And I wanted to include this in so that we could sort of appreciate this. This is from a company that is it's a web hosting company, but it's also one of the few companies that has been acknowledged as keeping track of this and being allowed to keep track of this, because as you can imagine, if you write a web crawler that scans a website, you're very likely to get yourself knocked off the internet. And so this is one of the companies that has been granted exceptions to this, or been allowed to do this, or at least acknowledged to be doing this, keeping pretty good track of it. Once again, I've provided you with a link to their updated monthly site that sort of gives you an overview of how the web has grown. The main thing that I want to point out on this graph is that notice that this is a logarithmic scale, not a linear scale. And so it really gives you some appreciation for the growth of the web. The other thing you'll notice here, and I do not have this slide as being interactive, you'll want to go to the website for this, but you'll notice that the letters on the host names plot. Well, each one of those will indicate a particular entry or exit from the landscape, if you would, for a particular feature. So in other words, for instance, when did a particular web server come online? When did a particular milestone get reached, and so on. And so the idea here is also that you'll notice that there are active sites and host names. And the idea is that you can have multiple host names that might map back to an active site, or you might have reserved a host name and do not have an active site to back it up. And so that's the reason for the two different numbers. Now, lastly, where is the web going? We've talked a little bit about where it came from, but where is it going? We'll start off with Web 1.0. And this is the idea then of those static pages, static website, serving up constant information. Think early 90s up through to the early 2000s. And the idea is that you might have, for instance, a site that will allow for you to do basic retail sales, information, news, and so on. Then what made the distinguishing characteristics of Web 2.0? Well, Web 2.0 essentially moved the ability to do content creation to the users. In other words, things like Facebook, Twitter, etc., these social media platforms that we now take for granted, essentially allow for you to be content creators. For example, I'm creating this video and I'm going to probably post it on YouTube. That idea right there of me being able to contribute to the web as an individual, not necessarily a web developer, not necessarily going through a traditional hosting company, but creating content, pushing it to the web, is fundamentally what distinguished Web 2.0. And so the idea of this is that pretty much anyone can be a content creator on the World Wide Web. Moving forward, where are we going with this? Well, with Web 3.0, which is sometimes perhaps confused with or aligned with the semantic web, there's still some debate about the definitions of both. Where are we going with this? Well, in both Web 3.0 and semantic web, the idea is that basically instead of having a single repository for information, for instance, our Wikipedia links, you can combine resources from multiple locations. And so the idea is that this is all done in some sort of machine readable fashion, which is the reason I said that we don't want to think in terms of classic web browsers. You want to think of them more in terms of web clients, and a client may or may not have someone physically on the other end of the keyboard. And the idea is then that you can aggregate information from multiple different sites. And so a couple of examples I could give you is, imagine, for instance, that you had this really nice travel application where it could tell you a little bit about the destination that you're going to, maybe the history of the city, but also somehow it magically figured out what days you were traveling and then giving you the weather forecast, all integrated into one experience. There isn't necessarily one site that will hold all that information, but then that your client can then reach out and aggregate multiple pieces of information. In that particular example, it might be some historical information like a Wikipedia article, your travel itinerary, as well as the weather forecast. So that'll sort of give you an idea of what types of applications we would want to be building in the future. Other aspects of the web that we need to consider are some of the sociological impacts of the web. Now, I'm not going to go into great depth on this. This is meant to be a little bit of a self-exploration on your part. But what I want you to do is I want you to consider some of the aspects of the web that you probably haven't thought about before. First and foremost, things like socioeconomic. This one was brought to light by COVID, particularly when we all asked people to work from home. That made a tremendous assumption that you could afford to have high-speed internet at home. And so if you think about it for just a second, if you are in a rural part of the state, or perhaps you've just chosen not to have internet at home, then that can impact your ability to use the web. And as you know, you probably get a different experience if you are tethered to your phone versus if you are on a high-speed internet connection. And so little things like, for instance, the size of an image, in other words, what's the resolution of an image, can control then the user's experience. And so there are multiple aspects of this when you start looking at both socioeconomic as well as socio-technical. An additional topic to consider when you're thinking about socio-technical is things like ageism, for instance. In other words, are we implying that a particular user can or cannot use a feature? Now, once again, I'm not saying that there is necessarily this built into web development, but rather that it's something that we do want to consider when we are designing our sites, or for that matter, anything with respect to the web. Educational aspects are another example. In other words, how we learn has changed significantly, particularly with the invention of Web 2.0, or rather the advent of Web 2.0. And the idea is that everyone can be a content creator. Well, that's great, because two things. Number one is you have a lot of content creators, and potentially you have a lot of content covered. However, the bad side of that is the quality of it may be a little bit suspect. So you have to have curation in addition to creation. And once again, that's just simply one of the aspects of the web that we need to consider when it comes to educational. And then lastly, accessibility. We make some grand assumptions about our users, mainly in the particular web, in context of web development, that they can easily see the page. And so being able to have a web page that can be read, for instance, by a reader is very important, because that then improves the accessibility aspects of web use. In other words, it could potentially be the difference between someone being able to read the daily news and not. For instance, if the site is written in such a way that one of the accessibility readers can't handle it, then they perhaps can't get their daily news. And as such, there's a couple of other things that we can take a look at when it comes to sociological impacts of the web, but I would encourage you then to dig into this a little bit further. Maybe you've been personally impacted by one of those. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me, and thank you for watching.